So this next one is an equation, but it's got multiple angles, all right? But look at the patterns here, right? So look at what we've got here. We have sine of something, an angle, minus sine of a different angle equal to 0. Okay? So this pattern, sine of an angle minus sine of a different angle, is from here. Right? Sine of an angle minus sine of a different angle. So we're going to apply that to this. So that's 2 cosine 8x plus 2x over 2 times sine 8x minus 2x over 2 equal to 0. So here I get 2 cosine 5x sine 3x equal to 0. Okay? Now, so the 2 goes away, right? You can divide out the 2. So what is it that we have here? We have cosine 5x equal to 0. And we have sine 3x equal to 0. All right?
Wait, I'm sorry. Did you just forget the 2 then?
Well, no, we divide both sides by 2 so it goes away. Okay? So now, what is this telling us? This is telling us that we're looking for where cosine is equal to 0, right? When is cosine equal to 0? Right. So cosine of theta is equal to 0 when the angle is pi over 2, 3 pi over 2, and so on. Okay? In here, what is the angle? Is it x? No, how much is it? It's 5x. So instead of saying, x is equal to pi over 2, 3 pi over 2, and so on, we say 5x is equal to pi over 2, 5x is equal to 3 pi over 2, and so on.
Could you also say 5 theta?
Huh?
Could you say
Right, yeah, you can, but here it's given an x, so we stay in x. Okay? All right? But also, if we're going to do it for like all values of theta, okay, then is it going to be plus 2 pi n? Plus 2 pi n? Okay? So far, everything is sort of the same because we're like, okay, cosine is 0 when the angle is pi over 2 plus 2 pi n, 3 pi over 2 plus 2 pi n. Okay? The only thing different is the angle we've just like copied down 5x. But ultimately, I need to solve for x. So what I do is I divide everything by 5. Okay? Okay? So I have x is equal to pi over 10 plus 2 pi over 5n. X is equal to 3 pi over 10 plus 2 pi over 10. I'm sorry, 2 pi over 5n.
Can the 5 only be under the pi? Not.
No, it could be
It could be
like,
whole...
yeah, it could also be, yeah, it could be the whole
2 pi
thing.
over
Yeah,
5. Okay.
Okay? So, next one is sine of 3x is equal to 0. Sine is 0 when the angle is 0 or pi. So when the angle is 0 or pi, right? Plus 2 pi n plus 2 pi n. Okay? But then what do I need to divide by? So this is 3x is equal to 2 pi n, right? The 0 goes away. So then what do I divide by? 3. Divide by 3, divide by 3. So x is 2 pi over 3n. X is pi over 3 plus 2 pi over 3n. Okay? And those are the answers. All right. Okay, so we have cosine 4x plus cosine 2x is equal to 0, right? And that's going to be this one with the red star, right?
Yeah.
Cosine plus cosine. So it's going to be 2 cosine a plus b is 6x over 2. Cosine a minus b, 2x over 2, is equal to 0. Okay? So 2 cosine 3x cosine x is equal to 0. What happens to the 2? Goes away. Good. Here I have cosine 3x is equal to 0. Cosine x is equal to 0. Here, what do I write down? What equals what? Where does cosine equal 0? When the angle is how much?
Pi over 2 or 3
Pi over, so what do I write then?
Cosine 3x equals.
Not cosine.
3x.
3x equals pi over 2. Yeah, 3x equals 3 pi over 2. Okay, so listen, not to like add more stress on you guys. I'm totally fine with you guys doing it this way. Plus 2 pi n. Plus 2 pi n. But if you also wanted to do 3x is equal to pi over 2 plus pi n and combine these two, it also works. You see what I mean? You know how like when it was pi over 2 and 3 pi over 2, we could do plus pi n instead of doing each one separately? Am I going to take points off if you do one versus the other? No. But just letting you know, like mathematically, that also works, huh?
Can we do one like that?
Yeah, so let me do this.
How did you get pi over 2? Like, what's pi?
So remember, okay, so we have, it works on pi over 2 and 3 pi over 2, right? So we said you could say that this is pi over 2 plus 2 pi n, 3 pi over 2 plus 2 pi n.
Oh, instead of having two different.
Instead of having two different ones, you could also do pi over 2 plus pi n, in which case you still divide by 3. And so you get x equals pi over 6 plus pi over 3n.
And like if it was pi over 4, you could do plus pi over 2.
Right. If it was all of them.
Right.
So that's one way to do it. But if we continue this way,
Are we ever gonna have
no. But I'll get back to that. Let's continue doing it this way. Let's just keep it more straightforward and basic if you want to. Listen, it's 110% your decision, okay? Divide by 3, divide by 3, divide by 3, everything divided by 3. X equals pi over 6 plus 2 pi over 3n. X equals pi over 2 plus 2 pi over 3n. Okay, and then here we have cosine of x equals 0. Back to the basics for that one. So you just say x is pi over 2, 3 pi over 2 plus pi n, plus 2 pi n, right? Okay?
Yeah.
Now, you can write it like this. The book may or may not write it in this way up here. That's why I kind of was telling you about it. So when you get your answer like this, and the book tells you pi over 6 plus pi over 3n, don't freak out that you did the whole thing wrong. Just know that it's that, other way of writing it. Yeah.
What if, like,
Try this one. It says cosine of 2 theta is equal to that. Okay? So we're going to verify this. Let me just write it out again.
Isn't that just like an identity? Yeah.
Huh?
Don't they just equal each other?
Yeah, but we're trying to verify.
We're trying to prove that they do.
But how?
But like the one like we did in the other one. So start with this left-hand side, cosine of 2 theta. Remember how before we did this before? Here, right? We had to verify these things. You remember?
Oh yeah.
And here as well. So we're going to do the same thing. So what's another way that we can write cosine 2 theta? Is that cosine theta plus theta?
Yeah.
Yep. And now look at what I have. I got cosine A plus B. So that's cosine, cosine, sine, sine. So cosine minus sine, sine equals. Okay? Well, what do I have here? Cosine squared theta minus sine squared theta equals, let me write that again. What's the issue here? I have two different functions. But can I maybe, okay, so I have a cosine squared and a sine squared, but I need it to all equal cosine squared. So I need to get rid of the sine squared fast, right? What's one way to get rid of sine squared and make everything into cosine squared? Is there an identity? Pythagorean identity.
Woo!
Woohoo! So cosine squared theta minus, what's sine squared theta? 1 minus cosine squared theta. While distributing the negative, cosine squared theta minus 1 plus another cosine squared theta. Ooh, what do we have here? That's 2 cosine squared theta minus 1 equals 2 cosine squared theta minus 1. Right? Identity verified.